If you learned calculus the way most of us did, your teacher handed you a bag of tricks. Substitution, parts, partial fractions. Memorize them. Pray you pick the right one. But here's the secret nobody told you. These aren't tricks. Every single one is a differentiation rule played in reverse. By the end of this video, you'll never guess which technique to use again. You'll just see it. Let's start with the chain rule. When you differentiate a composed function, the derivative of the inside gets multiplied on. Look at that leftover factor, g prime of x. That's a fingerprint. The chain rule always leaves it behind. So flip it. If you're staring at an integral and you spot a function and its derivative sitting next to each other, you're not looking at a hard problem. You're looking at a chain rule that already happened. Watch. The inside function, x squared, call it u. Its derivative, 2x, is right there. So the whole integral collapses. Substitution isn't a trick. It's playing the chain rule backwards. U-sub is just rewinding the tape. Okay, but what about integration by parts? That formula looks like it was invented to torture students. Here's the thing. You already know where it comes from. It's 3 lines of algebra away from the product rule. That's it. That's the whole formula. The product rule creates 2 terms. Integration by parts lets you trade one for the other. And there's a picture that makes this unforgettable. The 2 integrals are 2 regions of the same rectangle. If one region is ugly, compute the other one and subtract. That's not a trick, that's a trade. Now, partial fractions. And here I have to be honest with you. This one breaks the pattern. It doesn't reverse a differentiation rule. It does something arguably smarter. It refuses to fight the problem at all. It restructures it. That scary rational fraction, it's secretly the sum of 2 baby fractions, and each baby fraction is something you could integrate in your sleep. So the strategy isn't reverse a rule, it's change the shape of the problem until an easy rule applies, which honestly is the deepest idea in this whole video. Most hard problems in math aren't solved, they're rewritten. So let's put the whole picture together. Every integration technique you know is one of 2 moves. Either you're rewinding a derivative rule, or you're reshaping the problem until you can. Next time you face an integral, don't ask which trick, ask which derivative rule could have produced this, and if none did, how do I rewrite it until one does? But here's a question. What happens when a single integral needs 2 of these moves at once, and one of them creates an infinite loop that somehow solves itself? That's video 8. Subscribe so you don't miss it.